All right, here are some solutions from, I guess this was our second perfect problem for Math 211. We're given this set, 5, 6, 7, 8, 9, 10, and asked to consider this relation where an element is related to another element if the base 2 representation of the first element is longer than the base 3 representation of the second element. So, might help to visualize this a little bit to actually sketch out the sets. So I got 5, 6, 7, 8, 9, 10 as the set on which my relation is defined. And since it's just defined on that single set, that means relations go from that set to itself. In other words, from one of these elements to one of these elements. And you decide whether or not you should draw an arrow based on whether the base 2 representation of the first number is longer than the base 3 representation of the second number. So for example, there should be an arrow from 8 to 6. So what about the rest of the arrows? Well, for me, I think it helps to write all the numbers in base 2 and base 3, just kind of off to the side, just so we kind of have them as reference. So if you were thinking about donuts in our donut shop, that's kind of how we introduced this. The number 5 would be one single donut, no boxes of 2, and one box of 4. And the number 6, we'd have a box of 4, a box of 2, and no singles. Number 7, we'd have a box of 4, a box of 2, and a single. 8, we'd have a box of 8, no boxes of 4, no boxes of 2, no singles. 9 and 10. And then at a base 3 donut shop, let's see, for 5, we would have one box of 3 and two singles. For 6, we would have 2 boxes of 3 and no singles. For 7, 2 boxes of 3 and 1 single. For 8, for 9, and for 10. Oh, no. For 9, we would have 1 box of 9, 0 boxes of 3, and 0 singles. Couldn't write a 3 there because the number 3 makes no sense in base 3. Only the digits 0, 1, and 2 make sense. So here are my base 2 representations and my base 3 representations. And essentially, I want to draw an arrow from any element over here so that its base 2 representation is longer than its base 3 representation. So 5 should go to 5, 6, 7, and 8, but not 9, because this uses 3 digits and so does this. You could draw all those arrows, or you can get kind of clever about this and recognize that all of these elements have length 3, and all of these elements have length 4, and all of these elements have length 2, and both of these elements have length 3. So essentially, from each one of these elements, I am going to draw an arrow to each one of these elements. And from each one of these elements, I'm going to draw an arrow to each one of these elements and each one of these elements. So you could draw in all the arrows if you want, but I think it makes it easier to visualize if you just draw these arrows, if you want them directed. There, now they got little arrows on them. As long as you understand what you mean by this picture, I think that'll suffice. So now let's go answering some questions. The first question is it reflexive? Well, it's reflexive if there's an arrow from 5 to 5, there is. 6 to 6, there is. 7 to 7, there is. 8 to 8, there is. 9 to 9, there is. And 10 to 10, there is. Reflexive. I would say yes. And the reason why is because A comma A is in my relation for all elements for all A in my set. What I'm saying is for any element you choose, there's an arrow from that element to itself. Well, symmetric. Well, to be symmetric, anytime you have an arrow from an element over here to an element over here, there must also be an arrow from the element that you talked about over here to the element over here. So that's a little bit tricky. I think it's easiest to figure these out by thinking about what arrows you don't have. So the only arrows that I don't have are arrows from these 3 elements to these 2 elements right here. So there is not an arrow from 5 to 9, for example. However, there is an arrow from 9 to 5. So one way you could show that it's not symmetric is no. Maybe no exclamation point. Note 9, 5 is in R, but 5, 9 is not. You only need one counterexample to show that it's not symmetric. This relationship is reflexive, but it's not symmetric. What about transitive? Well, to be transitive, you need to, maybe it's easier to talk about what's not transitive. For something to not be transitive, what I need are elements A, comma, B, and elements B, comma, C in my set, and also element A, comma, C not in my set. So I need these two to be in there and this one not to be in there. So let's go back and look at the picture and see if we can talk ourselves into this. Let's see. Again, it might help to think about what arrows are not included. So there are not arrows from these three elements to these three elements. There's not an arrow from 5 to 9, from 5 to 10, from 6 to 9, from 6 to 10, from 7 to 9, or from 7 to 10. So the question is, could I get from any of these three elements, 5, 6, or 7, to these elements 9, 10 by going through another element? And I think you can. So for example, there is an arrow from 7 to 8, right? There's certainly an arrow from 7 to 8 because the base 2 representation of 7 requires 3 digits, and the base 3 representation of 8 requires only 2 digits. So there is an arrow from 7 to 8. And there's also an arrow from 8 to 9. So there's an arrow from 7 to 8 and an arrow from 8 to 9. So there better be an arrow from 7 to 9, otherwise my relationship is not transitive. And there's not. There's not an arrow from 7 to 9. So transitive? Hell no. No, it's not transitive. And I'll say note. I should use the exact example I just talked through. What did I say? 7 to 8, I think? I think this was the example I used. Note 7, 8, and 8, 9 are in R, but 7, 9 is not. So it's not transitive. 7 to 8, sure. 8 to 9, sure. 7 to 9, nope. So there you go. It is reflexive. It's not symmetric. It's not transitive. So what does that tell us? Is it an equivalence relation? No, because to be an equivalence relation, I had to answer yes to all three of these. So equiv, I'll write it out. Maybe spell it wrong. Equivalence. Is that how you spell that? Equivalence. I think I spelled that right. Relation. Maybe these should all be question marks. Transitive? Question mark. Symmetric? Question mark. Reflexive? Question mark. Anyways, equivalence relation? Nope. No, because I didn't answer. No, not symmetric. That's sufficient. To be an equivalence relationship, I had to answer yes to all three of these. And I didn't answer yes to all three of these. For example, I didn't answer yes here. It's enough to just say it's not symmetric, so it's not an equivalence relationship, but it's also not transitive. That also would be enough to say it's not an equivalence relation. What about a function? Nope. To be a function, you can only have one arrow going from an element to another element. So 5 goes to 5, as we already talked about. But unfortunately, 5 also goes to 6, and that's enough to say this is not a function. 5, 5, and 5, 6 are in R. And you can't have an arrow from 5 to more than one element, and I do. 1 to 5, 1 to 6, therefore it's not a function. Did I answer all the questions? Ordered pairs or listing an arrow diagram. Yeah, I kind of shortcutted that, but whatever. Answer these questions. I did all that. I suppose that right there can end this video, and I'll call these the solutions, or at least solutions light.